Hey YouTube, JP Dillon. Here's another one of my crusty collection. This was given to me, and you can see it spent some time near the ocean. A lot of time. It's about a 77 or 78 Kenwood ka-8150 dual power supply, fairly hefty amplifier by the looks of it. Peering in there you can see big heat sinks and big transformers. Haven't turned it on yet. I have no idea what this thing does or does not do. So let's take it apart. Let's do some brief testing and make sure there's no shorted output transistors or nothing. And then let's turn it on and see what happens. Alright, so here's the innards. Also a little crusty. But you can see it's fairly well laid out. What I don't like about these generations is that they cram the power supply and the preamp up against the front panel, and the heat generated by the regulators over here like to cook things like the soldering. We'll look at that in a little bit. This has the infamous Sanken 2SA747 and 2SC1116, which are fairly rare and valuable. Good ones, real ones, not counterfeits, will set you back about 12 to 15 bucks a piece. So hopefully those aren't bad, because if it is, I'll probably just part it out, given the fact that it's kind of barnacly looking. So the next thing let's do, grab a hold of this, flip it up. What you want to do with these is look at the soldering on the back panel, and we can see, if I zoom in a little bit, see how the heat just attacks the solder and it gets all crystallized and ugly looking? So it's going to be like that in the area where this power supply board is. I don't think I'll have to take it up. Usually the capacitors don't go that bad. Usually just the ones adjacent to the regulator like this will get testy. And then we gotta clean all those pots and stuff. But that's really moot at this point. What I want to do is grab my meter here, and we'll set it on our diode function. Hang on just a second. And we'll just do a brief test to make sure there are no short circuits. Alright, I'm going to have to put the camera down for a second. Alright, so the left side checks out. Camera might fall when I'm doing this, so if it does, I apologize. We're just going to touch the lead to the collector and the other lead to the base and emitter on the right channel. We don't get any shorts there. No shorts there. Alright, good. So that means that the amplifiers aren't shorted. And if I take up the camera here and we take a look down inside the power supply, and we look at those high voltage fuses there, there's one down there and there's another one there. Come on, focus. They don't appear to be blown, and likewise for the other channel, they don't appear to be blown either. That one's still intact. That one kind of still looks intact there. Alright, so the next thing to do is just to hook it up to a load and see what happens. Alright, so it's hooked up to a load and a signal generator. Let's see what happens. Yeah, get the protect relay, that's good. We're on aux. Turn all this loudness crap off. And let's advance the volume, see what we get. So far, nothing. Nope, still nothing. I don't get as much of as a blip out of it. Make sure we don't have a dirty switch or anything like that. Nope. Doesn't appear to be. Huh. Nada. Let's just make sure that I'm getting signal in here. Yep, signal generator is working. Alright, let's pull the pre-out main in jumpers on the back, which are these little horseshoe things down here. And we're going to plug our signal directly into the main in. And then we'll turn the signal down a little bit. And then we'll see if we get sound. Alright. So the amplifier works, because if I go directly into the power amp input, we get sound. And it's clean and undistorted. Wow, quite a bit. That's pretty powerful. Let's see how much power that actually is. Let's find a good ground. Yeah, let's set our meter to AC. 27 volts RMS on the right, 27 volts RMS on the left. It's about 85 watts a channel. Not bad. But we need to find out why our preamp isn't working. And I'm going to go ahead and restore the jumpers so we can do some more troubleshooting. Oh, I noticed something. They were like this. But this is the pre-out, and this is the main in, so they were literally shorting each other out. Let's put them in the right way. Maybe it's that simple. Wouldn't that be something? Let's see if it's that simple. My little power indicator went out. Wonder if the switch went bad. Now I got nothing. The switches on these Kenwoods aren't great. Let's bypass it and see what happens. Alright, well, jumpered. The thing's still dead. Try another outlet here. No? Nothing? Maybe this chintzy little power cord is about on its way out. Because I don't get anything. Interesting. Okay. Well, let's ohm out the line cord and see what the hell happened here. Yeah, this is at the line cord. I'm measuring across the AC line cord. No change in continuity. So I think that we got a bad line cord. It's weird for it to just fail under tests like that. Very weird. Alright, so apparently my line cord took a dump. So I've got my cheater cord clipped across here in ghetto-tastic fashion. And so let's continue where we left off and see if it was that simple, just a jumper misplacement. And we got one channel. Come on. Man, touchy switches. Definitely that that mode switch is not happy. But if I play with it enough, Oh, and that filter switch too isn't great. Okay, it's time for some contact cleaner. I find it funny that the jumpers were installed that way. That was... maybe the guy was messing around with an external equalizer and he just didn't put the jumpers back in right, and then he's like, oh my god, I killed my machine. Those are crusty. Ugh. Bad switches. Okay, let's get some deox and hose this thing. Let's work these 3 buttons. These seem to be fairly sensitive. See, that's starting to help already. Then we'll work on that mode switch. This low filter button is like really touchy. Of course, most people don't use the filter button, so if all the signal's going through them and they get crusty, this is what happens. Man, oh man. I think the combination of the corrosion at the beach and sitting forever in one position kind of did these in. I'm going to hose them a little bit more here. At least it's playing in both channels. You can also see this phase shift that happens whenever the filters are on or off. Interesting. Man, those are crusty. And then you got this loudness control, but that really doesn't have too much sensitivity to it. It's like way down in there. Can't even really see it from here. It smells like something's getting hot. It's probably this regulator here. Amplifiers. This one's a little bit warmer than the other, but whatever. Let's see if we can dribble some contact cleaner in this mode selector switch. That one cleaned up okay. Yeah, the input selector at the back there isn't great. It's starting to come back alive. That tape monitor switch isn't great either. Those are those slotted looking guys down in there. I'm not really too concerned about messiness right now since this needs to get cleaned up. So we're just going to hose them. There's still like a channel disparity, but that could just be dirty volume pot or balance control, because that's not great either. And then the input selector is this big slide switch mounted on the back here, which is kind of a pain to get to, but you can get in there and we'll just hose it. Like I said, I'm not too worried about it being perfect right now. I just want to get it so that it plays. Then we can work all the bugs out later. Okay, so that switch is non-touchy. We got speaker selector, which is this guy down in here. We'll just hose this. Much better. Still got a little channel disparity, but yeah, crusty volume control, which is this big guy down in here. I don't know if you can see that. Let's turn the light on. So the big guy is the volume control there, and then the little guy here is your balance control. So there's a hole. It's hard to see. There's a hole at the top. That capacitor is obstructing the view, but it's in there. And then let's see here. There's another hole at the back there. We can get that down into. And then that's our balance control. So we'll just turn that. That's cleaning up really nice. You really can feel the heat coming off of this board where the regulators and stuff are. It's a bad design. They really shouldn't have designed it that way. And we'll turn to a blank spot here so we don't keep blasting things. You can see the noise disappearing as the control gets cleaned. See, now it's almost no noise. Interesting to see how it cleans up on the scope. Then we'll just go back here. We still have a little disparity. Let's see if that's just in the lower portions of the volume control. Maybe when we crank it up it won't be disparity. Nope, there's still a disparity and it gets worse. It's quite a bit. There's more amplitude in the left than there is the right. I wonder if that's frequency dependent. It is. Look at that. See how the left one gets bigger as we turn it down? I wonder if the loudness control is to blame for that. Oh yes. If we touch the loudness switch. Alright, so that's kind of in an off position. There we go. That's linear again. So we need to clean that switch too. Big surprise. But it's coming around. It looks normal. It looks pretty damn normal. We still need to clean the rest of the pots and do the resoldering work on the regulator board and probably take the bottom cover off. But yeah, that'll be part 2. We'll just leave you at this. Stay tuned, more to come.